I'm actually very excited about this fireside chat. It's one of the companies that I'm really excited about in our portfolio. I'll just take a minute to introduce Kobi. So Kobi is what I like to call a serial entrepreneur, an investor, by the way, with over 15 years of experience in leading technology, media startups, and seed stage companies to acquisition. Kobi was founder and president of Taptica, acquired by Marenko, and founder and CEO of Logia, Americans like to call it Logia, a mobile contact platform acquired by Mandalay Digital. I'd like to start with a story about how it all started with Arbe, which I find a little bit charming, a little bit fascinating. So Kobi actually met Noam, the CTO of Arbe, at his previous company. And Kobi, working as an entrepreneur and investor for many years, he told Noam, when you're ready to start something of your own, come to me and I'm going to be your first investor in the company. I promise to invest $100,000 in your company. A while later, knock on the door, so to speak, Noam comes to Kobi, and Kobi didn't only see this company, but joined forces as co-founders and became Arbe CEO. So this kind of fairy tale story, happens every so often, but I think in this case, really coupling, bringing together very unique experiences and talent to form the core team of Arbe. So Arbe is doing, I'll say in a line what I think, and then you'll elaborate on that. Arbe is really positioned to do for the autonomous vehicle in the radar space what Mobileye set forward to do in computer vision. This is quite extraordinary and revolutionary. Tell us a little bit more.
Okay, so first, good morning, everybody. Great to be here. iAngels were our partners for almost 3 years now. And they actually first gave us money when the idea of taking the radar to car was a bit of a simulation, I would say. And
it's a really nice slide.
Yeah, and they were supporters of us since then, and in every round, including helping us bringing the investors, developing the strategy, and finding our right message to the investors. So I see more as a partner like I see Noam. So it's we are in the family. Yes, so Arbe, as Mo mentioned, was founded almost 4 years ago. I can say that even though the idea of Noam was great, there was another reason. I was at that time with my young daughter that was just born, and she was a baby. And it was a bit of temptation to go and found another company at that stage. So I left the diapers. And Noam came with the vision of, he actually did his master in radar and his PhD in autonomous movement of robots. And he came with the idea that the only way to solve the real problem of sensing of robots in the complicated environment is by doing a ultra high resolution radar. And this is where we started, and we had a simulation and an algorithm how to solve the problem.
Maybe let's take a second to explain why it's so hard. Why is it hard to have a high resolution radar?
So, first of all, the problem of high-resolution radar is a solved problem, but it's solved in the military. If you're willing to invest hundreds of thousands of dollars and you're willing to have something that is in the size of this table, the problem is solved. So the only problem that we needed to solve is to shrink it to a size of a mobile phone and to make it something that can cost to a car manufacturer $100. So, but
that's it. That's the only thing. That's it.
That's the only problem. So, to put it on a silicon and to find a way to do it. So there is few challenges that we needed to face in order to solve this problem. First of all, in order to have a high-resolution radar, you need to have many transmitters and many receivers. It's like, imagine a camera. With a camera, you have many pixels in the camera. The first cameras in the market were a very low-resolution camera, so they had a very low amount of pixels on the horizontal and on the vertical. It's the same like the radars that are today in the car. In the radars today in the car, there is 12 pixels. There is 3 transmitters and 4 receivers. In radars, the multiple of the transmitters and the receivers, this is actually the pixels. So the radars today have 12 pixels. In order to reach ultra high resolution radar, you need something that is 2 orders of magnitude more. So we have a 48 transmitters and a 48 receivers, which gives you 2,500 pixels. So in order to do that, we needed, first of all, to develop a new approach to transmitting and receiving. Because if you take the same 4x3 and you're trying to do certain like this, you won't reach anywhere. So we reinvented, let's say, the silicon of the radar. The second problem, which this is actually where we started from, we thought that this problem is solved, the problem of the transmitters and the receivers, and we just need to do like Mobileye, to do a unique algorithm and to put it on a silicon. Mobileye, for example, are not doing the camera itself. In the analogy of Mobileye, we are also a camera manufacturer, a HD 4K camera manufacturer. So when you're reaching to a high-resolution radar, basically you have a 2,500 pixels, but this is only 2 dimensions. The radar is a 4D sensor. So you have also 300 meters. And in these 300 meters, you have around 1,000 range bins. So the amount of pixels now is multiplied by 1,000, sorry. So you have, instead of 2,500 pixels, you have 2,500 and multiply it by 10. But the radar is not just 3D. It can measure on top of the range, it can measure also the Doppler. So there is another resolution, and you need to multiply the amount of points by 2,000. So if you're doing the calculation of it, you will reach to the number. The number is 30 giga per frame, and in order to have a car functioning based on your radar, you need 30 frames like this. So you need to process 1 tera of information in 1 second, which is undoable. Even the NSA cannot do that. So the main idea is how we are reducing this amount of data between the frames, and this is the core of our processor, and the core of the invention, and the majority of our patents are around this.
Yeah, I was going to say, it's not even one invention. We have, what is it, 10, 11?
Around 15 patents.
15
right
patents already.
Yeah, covering the technology, yeah.
So excellent. I think one of the things that I find fascinating about where we are in time, in terms of radar technology and how instrumental, or how it's going to really impact the whole industry and shape the whole industry, is the fact that all the major OEMs and tier ones, everyone has announced that, you know, radar is definitely going to be one of the core technologies in the autonomous vehicle, and this has already been, you know, stated on all the, you know, most important stages and, you know, screens in the world. But also the fact that we are literally at the verge of this thing happening, because in radar technology, unlike some other technologies, most of the most significant OEMs have said to choose a vendor in 2019, but no vendor has been chosen, and no OEM was won over yet by any radar company or radar competitor. So let's talk a little bit about this and how you are positioned in that competitive landscape.
So first of all, we're talking about autonomous driving, but we see autonomous driving like the landing on the moon. And we are more or less 2 years before Kennedy said that we will put a man on the moon on the next decade. So I think that a full autonomous driving is way, way, way ahead of us. It's the problem was mainly underestimated by majority of the car manufacturers. But in the middle, we will see a lot of new autonomous features in the car. So we build a platform starting from full autonomous driving, but can scale down easily to something that can get into an entry-level car and add to this entry-level car a basic autonomous functioning, full driving on the highway, traffic jam autopilot, those things that today are not even in the very high end of the cars can be done in an entry-level car with our technology. So this is in the core. Around the car manufacturers that using our beta, there is a part of them that trying to do a full level 5 even car without even the wheel. And there is many car OEMs that looking on this ability of turning what is today maybe in Tesla Plus, we call it Tesla Autopilot Plus, without accidents, into the mainstream of the cars. And this is the core of the technology. So we try to position the product as a very high-end and a very something that you can touch today. You can get it into the car today. When we're in the car, basically, it's a business that there is 2 or 3 competitors on each part of the cars. There is 2 or 3 companies that doing tires. There is maybe another 5, but 2 or 3 companies owning 60, 70% of the market. It's the same in camera. Mobileye controlling today more than 50% of the market, and there is another 1 or 2 competitors that doing that on top of it. On the radar today, there is 3 chip manufacturers that controlling the market. It's actually 2 controlling and 1 trying to get into. NXP and Infineon are controlling the market, and TI is trying to enter with the same product as NXP. It's even not a Me Too, I would say. It's a Me 3 strategy. We came with something that is completely different. The estimation in the market today is that we are between 4 to 5 years ahead of the current chip vendors with our solution. I think majority of the OEMs of the car manufacturers agrees that our product today is the most mature with the best performance and the best price. It doesn't say that we are mature yet, but we are the most mature among the startups that are trying to disrupt this industry. Another thing about radar is that there is today 2 or 3 startups trying to disrupt this industry. On the LiDAR space, there is more than 50 companies that raised more than $50 million and trying to build the next generation of LiDAR. So the market is less competitive from one hand. From the other end, it's a sensor that everybody agrees that there is a room for that in the car. Everybody agrees that there is a big market for that in the next 3 to 5 years. And now we stayed only with the problem of execution, which is
minor.
Minor, yeah.
I want to touch on another element that I find interesting in terms of why is there just a handful, just a few companies that actually have the ability to compete on radar technology. And I think it's something that you breathe in when you walk around Arbe's offices, the kind of expertise that is really required in order to be an innovator in the space, and where is that talent coming from? So when you visit Arbe's offices, you see a lot of people who have been working on chips and silicones for 20, 30 years. They're like almost, they come bent over this way to be able to look at the silicone, which is tiny. It's just as Kobi said, the size of a mobile phone. And to place things in such accuracy in terms of the antennas, in terms of how you place all the components. And I think from seeing talking to people who are coming in from the military to Arbe, it's very, very difficult to assemble such a team of professionals working for a company such as Arbe. So let's talk a little bit about that and what I think is interesting in terms of Israel and its ability to bring talent into that innovation.
So I think we have a good story about it. So when we our first design partner was GM. They have a radar R&D center here in Herzliya. And we did our first product in 24 gigahertz. It's a frequency that is the old radars in the car were in 24 gigahertz. And we tried to do a product that will fit also drones at the beginning. So we had our first PCB on 24 gigahertz and our algorithms and everything. And we came to GM and we presented them a ultra high resolution radar in 24 gigahertz, and they told us the one resolution is great, the 24 gigahertz cannot get into a car. So we said, okay, so we will do it in 77 gigahertz. What's the problem? It's 24, 77, it's just 3 times. So I remember the guy that is managing the radar told me, you are sitting on the table, near the table, on this chair. There were sitting 400 startups with the same story, and no one came with a product. So we decided that we will come back in with a product. And he told us 77 gigahertz, it's something that you don't know how complicated it is, and you cannot even imagine. So we said, okay, let's bring the best radar, the best talents in radar in Israel. So the first guy that managed, that did our antenna, was Professor Eli Levin. He was the managing of Green Pine product. Green Pine is the radar of the Arrow, the Israeli missile interception. So it's a guy that knows something about antennas. So he designed our first antenna. We did a tape out of the antenna. It's to produce it. Only the manufacturing takes 6 weeks. It's a very complicated thing. Some radar experts, when they look on this, they are looking on it like a draw of Picasso. They say that this antenna is a piece of art. So we got this antenna back, and it was, I remember, it was exactly 2 years ago. We didn't even had enough measurement equipment, so we went to a lab in the university, and we tested, and the antenna was working great, except of a small problem that it wasn't transmitting outside of the board. So on the board itself, the antenna was perfect, but no signal was sent to the air, which means basically it's better to have it for the Independence Day, because you can do with this antenna what we call mangal. Then Amos, that was at that time our VP hardware, he said, I have someone that was, and Ali Levin was at that time 65 years old. I have someone that Ali learned from him the antenna. It's called Ovadia Chaluba. We went to Ovadia and he looked in the...
How old is Ovadia?
Around 80. He was looking on the antenna and he said, it looks good. Please open the CAD, the design. He was looking at the design and he said, why you want it to transmit? We said, I don't know, we designed it to transmit. He said, yeah, but on the design you see that it cannot transmit. The signal cannot get into the air. There is here and here and here and here. You need to connect this and this and this and this, and it will transmit. So, you know, it was after 2 weeks that the entire team trying to figure out what's the problem, why it's not transmitting. I said, this is this and this, and it was actually in hours. So we did it. We send it to production, and then, of course, you need to simulate it. The simulation takes more than a week just to run the simulation because of the processing power, and this is in the cloud and Amazon and everything. So we send it, and of course, until it get back, we saw that even in the simulation, that the problem was solved, and our previous simulation was wrong. The simulation itself was wrong. Not just the design was wrong, also the simulation. So this is just to understand the expertise that is needed. Ovadia is someone that there's no even one satellite in Israel that is going live without him signing that the antenna is okay.
So I think it's really important for us. When we actually iAngels, we love a good challenge, and we love to work with companies where, well, let's just say we're not intimidated by like long cycles or working with larger enterprises, even if it's software, if it's hardware. So I think this is definitely something that you can't get past. It's not only the technology and the team, everything kind of like needs to check out. Working with the OEMs, working with tier ones, it's really quite a process. It's something that you need to take a breath. It takes a long time. It requires even a different kind of skill set in terms of the management team capabilities. How was that journey like for you, like working and engaging and trying to move around organizations like GM or others?
First of all, in my previous company, after 3.5 years, I was already at home after selling it. So, and here, I understand that it's a long run. I don't know if someone here is practicing running. So, this company is like you are practicing all of your life to be the best runner for 5 kilometers, and you're really good at 5 kilometers. And then when you're coming to the day of the competition, they tell you, today we will run marathon. Good luck. So I think this is something that at the beginning, it's really tough to even manage yourself in this situation, because you used to that if there is a bug, you tell all of the team to stay for the night, you order some pizzas, and hopefully in the morning it will be solved. And if not, another bunch of pizzas, another night, and it will be solved. And here, even if you found, in this antenna case, even after we found the problem, it takes 6 weeks for the antenna to get back, and then another 2 weeks for the bring up and to make sure it works. So everything takes time and time and time, and there's no room for mistakes, because each small mistake like this causes you huge problem. In our first tape out of the chip, the guy that designed the core of it is very expert in one of the components of the chip, the PLL. So he thought that his PLL, he doesn't need to recheck it before we are going to the tape out of the chip, because he's great in that. And obviously, we got back a chip from the fab, and the PLL was not working. And then you have 2 months of redesigning this PLL, after that, 3 months until the fab will produce you the chip, and another 2 months for the bring up. Of course, we found a way to bypass it and to launch a product without this problem. But every small problem can cause you delays that are in months, if not years. So it's a very complicated. And then you're getting, and all of those things is just the first course, and the main course is the OEM itself, the car manufacturer itself, that after all of those years, it brings you to another 3 years until you get into a car. So it's a real long, it's not even a marathon. It's real long journey. Yeah.
Ironman.
Yeah.
Okay, I want to open to a couple questions because before we run out of time and Kobi has to go, I see him constantly checking the time. Stop checking the time. Yes, one over there. Think, it needs to be good questions. Name, please.
My name is Assia. And my question is, so you're creating a better radar for the autonomous road. Tell us on how useful it is within the next 3 to 5 years. There's no autonomous going on. People like what you call it a superpower assist. What's the market there?
So the market for it is what is called today ADAS. It's a full adaptive cruise control, the next generation of adaptive cruise control. So the car can drive itself fully autonomously on the highway, manage itself, pass lanes fully autonomously, get back to the lane, drive itself. You can even text. There is now, I think, at least a few countries that decided that when this autopilot will be, you will be able to text during the driving.
Dream.
So it's a full autopilot on the highway. But you cannot go to sleep. So you need to be aware that it might be that the car will tell you you need to take control. So this is the market of it today. The assumption is that the end user is willing to pay for that around $2,000. So the car needs, the cost for the car manufacturer should be around $500, $600 for this package. And we believe that we can reach to this price point.
Next question. Yes. Behind you.
Yes, sorry. Peter Weinreb. I started investing in your company last year, and I followed all the rounds. There was an article a couple of days ago in the Jerusalem Post with the title, TAU radar research could advance autonomous car field.
Yeah, we saw that.
Can you comment on that?
Or
can it
we believe it's a good article.
Besides that,
besides of that, there's no real implementation of they did something that can work in a lab in a single transmitter and a single receiver. It's good. The idea is good, but it's not. There's no implementation of it. It cannot get out of the university.
As I'm having control of the mic, I'm going to ask you, what is the road to the IPO or to the exit?
Long.
How do you define long?
So when we believe that in 2022, 2023, we will be in the level of revenues and growth that Mobileye were when they went public. So the question of if the market in 22 and 23 will be good for IPO, I can't answer, but we are building the company that in 4 years from now we will be in the level of revenues and visibility. It's not just revenues. What I think made the Mobileye IPO so successful. Mobileye went public in $5 billion market cap, and a few years after they were traded at $10 billion, and then Intel paid 15. But what made them very successful on top of that they are an amazing company and their chip is great and their technology is great, is that they had a very good visibility on the next 3 to 5 years. So it means closed contracts, blocked contracts that they know they can deliver. So this is what we're trying to follow this model too.
I wanted to actually finish with that question, but I was... it was already asked from the audience, but let me ask you this as a final question. everybody's looking into 2022, 2023. What is the biggest challenge for you this year?
This year?
12 months.
So actually, in this business, 12 months is something that already passed. So
Gone.
it's no. Our big challenge today is we are today with a beta product, driving in California, driving in China, driving in UK, driving in Germany. Our big challenge is to make it a gamma. Gamma, we are in the final stages of taping out of our processor in the coming weeks. And the gamma is actually the product that will be able to get into the car. And we need to deliver it by end of Q3, early Q4. And this means that this is something that can really get into the car. We already have thousands of units that ordered for that. And the delivery is right now our main, we are managing it. Even though it's, it's 12 months, it's managed on a daily basis. It's there is 2 project managers. We have the product itself and the post-processing. So it's 2 project managers working in parallel on that. A daily status, daily mail. I'm not going to sleep without this daily mail. A morning meeting, it managed like war room, and Tuesday there is elections, the office is open, so you're invited.
Thank you. One last question? Yes.
So we're talking about a long journey and a marathon, whereas it might sound appealing to have kind of a short 5K. So the question is, given that it's a long marathon, what's the potential? I mean, if somebody offered you $1 billion now to sell Arbe, would you?
First of all, it's not my decision. We have partners, and I believe that this amount of money is not something that will be easy for us to say no. We are not planning for that. We are here for the long journey. We are here to build. Noam, my co-founder, is fascinating by the fact that he will be able to solve the problem. Is not his main ambition is to solve the problem. We can have an easier path just by building, for example, a chipset company. We can be just a fabless company that delivers chipset, and someone else will solve the problem. We are actually, what we are doing in Arbe is 2 companies in one. It's also divided by this. There is the R&D that is doing the chipset, and there is, in parallel, R&D that's solving the problem, trying to solving the problem. And we are fascinating about solving the problem, and not about, the exit. It's not, I don't think that you're building a company for exit. You're building a company to solve the problem, to do a great product. And apparently exits comes to those kinds of companies. But there's no shortcut for that.
Thank you.
Thank you very much, Kobi. It's a pleasure.